Hello everyone, so this is the video lesson 33 and here I am going to explain the single slit Fraunhofer diffraction of the light. Okay, so there is a single opening, there is a single slit through which the plane wavefront of the light passes, and each point of that opening is the source of secondary wavelets, and these wavelets emerges out towards the screen and superimposed to each other, and due to the superposition of the n simple harmonic waves, a pattern and an intensity distribution is obtained on the screen, and that intensity distribution is called the Fraunhofer diffraction pattern. Okay, so here I try to draw the figure for this diffraction. Okay, so you can see the figure for the Fraunhofer diffraction due to the single slit. Okay, so there is a source capital S, and this is a monochromatic light source, and from this source a spherical wavefront is emerges. The spherical wavefront emerging from the source S after passing from the convex lens L1 is converted into the plane wavefront, and that plane wavefront fall normally on the slit. Okay, so this is the this satisfy the condition of the Fraunhofer diffraction. The condition is that the source and the screen should be at infinite distance from the slit. Okay, so a plane wavefront is falling on the slit. Each point of the slit here act as the source of the secondary wavelets. These secondary wavelets emerges out towards the screen on this side, and they get superimposed, and due to the superposition there is a intensity distribution on the screen, or you can say that there is a diffraction pattern on the screen, or this is the bending of the light. Okay, so here you can see that the waves which are not diffracted are shown here by the red rays, and they collect at point C on the screen. However, the waves which are diffracted by the amount theta is now focused by the lens L2 at point P on the screen. Okay, so there are small n harmonic waves. Okay, these are the small n harmonic waves of equal amplitude and having a constant successive phase difference between consecutive waves delta fall normally on the slit. This is the opening. Here AB is the slit. The width of the slit is small e, and when they passes from the slit, the phenomena of the diffraction takes place, and due to that phenomena there is a intensity distribution on the screen. Okay, so this is the figure. Now let's see the simple drawing for this effect. So there is a plane wavefront, and this is the opening single slit, and you can see that the light is diffracted as more and more as we move from the slit towards the screen. And suppose that there is a screen, so you can see a pattern, an intensity distribution on the screen. So here in front of the slit, this is the line of experiment. Here theta is equal to 0. You can see that. What is theta? Theta is here. Theta is this. Okay, so this is the line of experiment. This is the line of experiment. So theta is equal to 0 when we are talking about the direction of the experiment. Okay, so in front of the slit we obtain a bright band. Okay, and beyond this bright band there are alternative dark bands and bright bands on the both side. Okay, so this bright band is called as the central bright band or zero order bright band. Okay, and here this is the first order, this is also the first order, then after the second order bright band and the third order, and the similar order are also for the dark band. This is the first dark band, this is the second, and here this is the third. And you can also see that there is a basic difference between the diffraction pattern and the interference pattern, and the difference is that the intensity of the bright bands here is not equal for the all bright bands. Okay, you can see that the central bright band is central bright band have the highest intensity, has the highest intensity, while the intensity reduces as we move far from the either side of the central bright band. And here one thing is also important, that the width of the bright and dark bands, okay, the widths of the dark bands and the bright bands are also not equal. Okay, so here this is the actual pattern what we obtain on the screen. Okay, so this is the monochromatic light source, this is the light source of the green color. So the pattern is the modification of intensity, rearrangement of the light of the same color. And here I try to draw the intensity distribution curve. Okay, so on the x-axis, on this axis gives the intensity, however on the y plus y and minus y direction there is a theta, means angle. Theta is the amount of diffraction. Okay, so this is the line of experiment. Here at this line theta is equal to 0. So at theta is equal to 0 there is a maximum intensity, this is known as the central bright band. Then after, on the either side of the central bright band there is a first order bright band of reduced intensity, and then after second bright and the third bright and other bright with more reduced intensities. Okay, so this is the diffraction pattern. Now let's see this diffraction pattern more closely. Okay, so here I draw the diffraction pattern horizontally, and you can see that there is a contrast problem. Okay, because in interference all the dark bands are purely dark, but in diffraction there may be some presence of light. Okay, so due to the presence of some amount of light at the dark band, there is always some contrast problem between the bright band and dark band, and that's why the boundary between the bright and dark is not well defined here. You can see that. Okay, so this is another very important feature related to the single slit diffraction. Okay, so now this is the intensity versus theta graph. So here this is the central maxima, this is the first order, this is the second order, and these are the minima. The intensity is continuously decreasing far from the central maxima on the either side of the central maxima bright band. Okay, so however these are the graphs for the single wavelength. Here I try to draw the white, this is the spelling mistake. Okay, white light diffraction pattern, and you can see that the central maxima is of white, however the first order and this is the first order maxima, this is the second order maxima, and similarly on this side this is the first order, this is the second order,